Hey math kids, we're going to continue with 4.BD. Now we're on day 2, and we're studying probability in combinatorics. So we're going to go back to this idea. Probability is what you want divided by the total. So we're going to use that today, and we're going to use our NCR, which was n factorial over r factorial, n minus r factorial, and then NPR, which is just n factorial over n minus r factorial. Notice how those are similar, but this one just has an extra r factorial. Now, if you need a refresher, make sure you watch day 1 video before doing this one. So let's just jump right in with an example. So there are, there are 6 girls and 4 boys in a class, and the teacher wants to form a committee of 3 students. If the committee members are randomly selected, what is the probability that the committee will consist of all girls? Okay? So when we do this idea of what we want, in this case we want a committee of all girls. Now, since it's a committee and it doesn't, order doesn't matter, it's just any 3 students, not in a particular order, we're going to use a combination to figure that out. So first we just the want is how many all-girl committees we could create. So we're only going to look at this. We're not going to look at the boys. Now, there are 6 girls total, combination, and we're choosing 3. So we're going to say 6 factorial, 3 factorial, 6 minus 3 factorial. So that's going to be 6, 5, 4, 3, 2, 1 over 3, 2, 1, 3, 2, 1. I can extend that a little bit. Alright, so the 1, the 2, the 3 cancel. The bottom is 3 times 2 times 1, which is 6. The top is going to be 6 times 20. 5 times 4 is 20. Those 6's would cancel. So there's 20 all-girl committees that we could create. So that is going to be our want, the top of our fraction. Okay, now we need, for the total, we just want to know total number of committees that could exist. And so to do that, we now look at all the students, and we get 10C3. We're still choosing 3, but we have 10 to choose from. So we're going to say 10 factorial over 3 factorial, 10 minus 3 factorial. So that's going to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 over 3, 2, 1. And then 10 minus 3 would be 7, so 7, 6, 5, 4, 3, 2, 1. All this stuff cancels up to the 7. And then, let's see, we get 720 over 6, which I think I just did that on the calculator. Yeah, 120. So that's 120. So this is our total. So when we come back up here, we do what we want, 20 divided by our total, which was 120. So we're going to say 20 divided by 120. Go back to our calculator. And we get 0.166 repeating. Okay, if we round that to nearest percentage, we're going to say about 17%. So we have a 17% chance that we'll get an all-girl committee. Okay. Now we're going to look at another one. let's see. Let's do another one that's kind of similar to that. Okay, so let's say we have dogs and cats. We have 5 dogs, 7 cats, and we're choosing, I don't know, let's see. We go to like the Humane Society and we're picking out, and we're allowed to pick 2 animals. What's the probability that we'll get all cats? If we randomly select 2 animals out of this shelter that has these. Well, so this is a combination because it's just 2 animals. We're not ranking them. We're not having president cat and vice president dog. So it's combination. So we're going to do use our combination formula, which is NCR, n factorial, r factorial, n minus r factorial. And if we, we're also using the idea of what we want divided by the total. So what we want is all cats, and so we want to find the combination of all cat choice. So there are 7 to choose from, and we're only choosing 2. So we're going to say 7 factorial, 2 factorial, 7 minus 2 factorial. So that's 7, 6, 5, 4, 3, 2, 1. 2 times 1. And then 7 minus 2 is 5. So 5, 4, 3, 2, 1. These all cancel. So we have 7 times 6 over 2. So that's 21. Okay. Let's see. Alternatively, we could say 6 divided by 2 is 3, and then 7 times 3 is 21, like if you ever want to think of it that way. Now, this is our want, and then we also need to figure out our total. So our total this time, total animals, if we add these 2 together, we get 12. So we have 12 to choose from. We're still only choosing 2 animals, and so we get 12 factorial, 2 factorial, 12 minus 2 factorial. Alright, this is going to be a long one. So 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All over 2 times 1. 12 minus 2 is 10. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All that cancels. And then this is going to be 132 over 2. So what is that? That's, I don't know why I'm having a hard time with that. Oh well. Calculator, 66. So we have 66. Once again, that's our total. And so we just need to do 21 divided by 66. What we want, we can get 21 different ways, and then divided by the total number of ways we can get anything. And so that's going to be about 32% if we round it to the nearest percent. Okay, there's one more type of problem I want to go over. So it says Alex rolls a standard 6-sided dice. So 6-sided dice. He rolls the number cube 4 times. So rolls 4 times. What is the probability that exactly 3 of his rolls are 6s? Okay, so this isn't related to the combinatorics part, but it's just kind of thrown in here as a little bit of a review for the multiplication rule of probability. But what we're going to do, so we're rolling 4 times. So I'm going to set up 4 sets of parentheses. It's a 6-sided dice. So each time we roll, it's going to be out of 6. Now he rolls 4 times and wants exactly 3 sixes. To roll a 6 once would be a 1 in 6 chance. To roll it twice would be a 1 in 6. And the third time it's 1 in 6. Now in that last one, we don't want it to be a 6. So we have a 5 in 6 chance to not get a 6. So when we multiply this out, we multiply the tops together, we get a 5. 1 times 1 times 1 times 5. And then 6 times 6 times 6 times 6, or 6 to the 4th, is 1296. And then we just do 5 divided by that. And we get 0.00385. 0.00385. And so it's less than 1%. So it's actually 0.385%. So it is very unlikely that that will happen, but that's just how it goes. If you need additional help, please come to Math Lab. Until then, calculator.